Hey, well, anyone who was missing or just wanted to redo Thursday, Friday of September 17th and 18th. This is Mr. Block. And this is something we're going to start doing. We're going to have a video of me trying to condense a class down to 10 or 15 minutes. And that way you can reread it, rewatch it, and maybe learn some of the things that we're going to do. So hopefully this will work for you guys with hybrid coming up. And so let's start going. So this Thursday, Friday, we're focused on speed problems 1 and 2. And so you can see that that's what the slide was for today. The first thing we talked about was getting into Go Formative. So if you are not in Go Formative, then you need to meet with me. Just send me an email. I'll set up a meets and we'll get you into Go Formative. I think most of us are in there. And so that's not a problem, and I'm not going to go through it right now. But the other thing was that we said that when we assign homework or in-class work, we're going to grade it. Now, this is the first time in a long time that we're going to count formative work. It's because we're away from each other, and we need to get you guys motivated to do the work when we can't be over your shoulder helping you. So that's number one, why we're going to grade it. But number two is Go Formative is going to allow us to watch what's going on, to see how you're working, to see if you're just blankly just putting in things hoping that they'll be correct, because we want to make sure that we create the right habits. Okay, so the rest of the class then was getting into Go Formative and working on speed problems 1 and 2. And so I'm going to go through a list of the problems that we all asked during the class, and that's about it for this video. So I'm going to have a number of examples of the problems. I'm going to start with speed 1 and then I'll go to speed 2. I'll either do the problem for you or I will give you the hints that are necessary to get it right. Okay, so I'm going to turn off that and just go to pulling Go Formative over. First thing I want you to do is, if you missed today and you're into Go Formative, this is speed problems 1, and I'll move my picture here so I can make it look like it looks for you. So this is how a student view would look for Go Formative. You would come in here, there'd be a welcome, and there would almost always, well, we're going to embed a video right here. And that video will demonstrate, number one, what we want you to do, and probably do the first problem for you. So if you're like, I don't even know how to do the first problem, watch the video, take notes on it, or copy it into your notebook, and that will give you the format that you want to use for the rest of the problem set. So the other thing here is, in Go Formative, we're going to have a problem set like we would normally have in class, and these little buttons or little blue dots demonstrate that this there's going to be a question over here to the right that's going to relate to this question. And then so here we have 2 questions related to this one. And what we're doing here is, because Go Formative is really picky about how you type things in, we're going to have you type in the number first. That'll be worth 1 point. And then the units we're going to give you in a multiple choice kind of question, so that you can just choose between those and get used to always being concerned about your units. All right, so if, let's say, you're here and you're still haven't done problem 1, then what you want to do with this problem set speed number 1 is make sure you watch this video, because in this video I do speed number 1, and so I get the answer for you and show you how to do it. More importantly, it gives you a setup of the 4-column method that if you were to write it down, then the next 4 problems look fairly similar. You just have to make just adjustments based on the wording. Okay, so now I'm going to turn on the doc cam, and here is speed problems number 1. So we had our first problem that I've already done for you about the speed of the car, and then we have the second one of Usain Bolt and his 100-meter sprint. So these 2 are very similar, so I'm not going to do this problem for you. I really want you to watch this one, write down what you did, and then if you don't know how to do it, use this as an example on how to do this one. I just want to make sure that we get a couple of these things done to make sure that you are on the right track. So problem number 3 is different than problem number 2, only in that instead of asking us to find velocity, they're going to ask us to find time. And this is the one that we talked about in class that's a little bit more difficult. So I'm going to set it up for you. I'm going to show you the trick that we're going to use in the algebra, and I'm going to let you find the answer yourself. So anyways, whenever we do a problem, we always do them the same. We do the 4-column method. So we're going to pull out from the words. You say how much time. So that must be that they're asking us to find the time. So we write time is question mark. They tell us that thunder has to travel 1,500 meters. 1,500 meters, that's a distance. So we'll put down 1,500 meters. And then they say, if sound travels at a speed of 330 meters per second, that's a velocity. So we'll write down 330 meters per second. All right. Now this, again, allows us to look at the variables here and know that we're going to need the velocity equation. V, D, and T are in there. So velocity equals distance divided by time. Our second column, we just write down the equation, okay, from your reference sheet that's in your interactive notebook or in class, your yellow sheet that looks like this, that you'll always have next to you, all right? And it's the first equation, V average equals D over T, all right? The third column is the substitution column. And when I mean substitution, what I mean is we look through this list and we substitute if we have a number. So here we have V. Because we have a number for V, we substitute in that number, so 330. All right. Do we have a number for D? Yes, we do. We're going to substitute in 1,500. And then do we have a number for T? Well, no, that's what they ask us to find. So we're going to leave it as the variable. That's going to be our one variable. All right. Now we've always said that you guys are well equipped to do a lot of the algebra up here when the variable's in the top, but here it's in the bottom. And so that's one of the things we're going to stress this year is how to solve this problem. And what we want to say is whenever we see the variable in the bottom, our goal is to get it up top. So how do we get it up top? The trick that we said was we always multiply by t. If we multiply by t here on the right side, then of course we have to multiply by t on the left side. And so once we do that, we can see that t divided by t, well, those will cancel each other out. They'll become 1. And if we rewrite this equation now, t times 330 equals 1,500. Now this is a doable equation for almost everyone, right? T times 330 divided by 1,500. All we need to do is divide by 330 on this side, divide by 330 on this side. These cancel. We end up with t equals 1,500 divided by 13, or 330, okay? Make sure you get a calculator. If you don't, that's fine. We'll find one for you, but really right now, for a majority of us, we'd like to find a calculator. We put it in, and we get this number that t is equal to 45454 seconds. All right. The Go formula is going to ask you to round this to the hundredths, and so from that's where you're going to have to go from there. All right. The next problem, 4, asks you to find time, so it's almost exactly like that. So I've done this one. I'm not going to do this one for you. I want you to learn on your own. You could always come to win or whatever else if you're having trouble. Okay, how far will you travel if you speed walk 10 minutes? Okay, so here's the problem right here. Problem 5, if you're having trouble, what I just going to give you a hint, and that is if they give you a velocity in meters per second, then which of these two times should you use in the problem? Okay, our units should match. And therefore, when you do the 4 columns and you're writing down what they ask us D equals question mark T. Well, they give us 10 and 600. Okay, and since they're going to give us a velocity in meters per second, we're going to have to use the 600 seconds. Right? And then the velocity is 2 meters per second. Okay, and then you go forward from there. All right. If you're having trouble with 6, the problems with 6 are, number 1, this is a track, and because they're rotating around the track, and the track is 0.25 miles long, but they're going to do it 12 times. And so if we do it 12 times, we have to multiply by 12 times to find the distance. So your distance is going to equal 3 miles, I think it is, 3 miles. Okay. Now for the time, they tell us we start at 4 and we end at 4:15. So that's 15 minutes. Not very hard, except for the fact that they ask us to find the velocity in miles per hour. All right. And just like that one problem we just talked about, that means we need to figure out time. And what is time in hours? What's 15 minutes in hours? And for those of you guys who are worried, we're going to teach you how to do this, and we're going to teach you a method to do this. But right now, we're just trying to challenge your brain. And so one of the things that I always laugh about is that my kids cannot tell time on a clock. They just know the digital clock. And if they look at the clock, they can stare at it and eventually figure it out, but they don't know how. Okay. And so if I look at what 15 minutes looks like in a clock, well, 15 minutes looks like this, from there to there. And when I look at a full circle, I know that this area right here is 1/4 or 0.25 of an hour. And so the time here is 0.25 of an hour. All right. All right, last one is a very difficult one. It's our challenge questions. It's about the astronomy thing. The Earth is right here. The moon is right here. They're going to shine a light up to the moon, and it's going to bounce back like this, right? Now, what I'm trying to show you guys is that you can always do problems with the 4-column method, but sometimes you're going to need to draw a picture as well. So you'll do this problem with the 4-column method, and you're going to get an answer that's wrong. Okay, if you've done it correctly, meaning the 4-column method, you've done it wrong. They're going to give you, they're not going to give, you're going to get the wrong number because they ask you a little bit of a different question. They don't ask you how far the light travels, because the light travels there and back. They ask you how far the Earth is from the moon. All right, and so when you look at this picture, the distance that you found is from the Earth to the moon and back. But they've only asked you for what's the distance between the Earth and the moon. And so you'll have to do something with your answer to adjust for that. All right, speed problems 2. Really, they're all very similar to that. There's a couple of things that are a little bit more difficult, mostly with the last problem. So these ones are straightforward. They're designed to be straightforward with you. Just a little bit of a difference here where you're going to have to do 2 problems and then add up their distances because we have a guy traveling by train and then by bus. So you'll do 2 4-column methods and you'll add them up. This one's straightforward as we've been teaching. This one right here, we're just going to start giving you a little bit more words to sort through. But just remember, pick the distance. Not the distance from the classroom to classroom, but the distance that the student has to walk given the new routes that we're going to be having in school. And once we get here to these, right, we're going to keep pushing you. These are the 2 problems that really are A to B range problems, but what I want you, or B to A, like if you got a B and you want to get an A, you got to keep pushing yourself to get these kind of problems right. This problem is very straightforward. There's just a little bit about testing you about what you know about decimals for time. If you don't get this problem right, don't worry, it's not worth any points. And then this last one, I just want to show you the picture. So what happened in the Apollo 13 mishap was here's the Earth and here's the moon. And the Apollo 13 astronauts left the Earth and they were on their way to the moon. It takes a significant amount of time because it's 238,000 miles. And right about 138,000 miles away from the moon, I think it's 137,000, something happened and they really crippled their spacecraft. and there was an explosion, and they crippled their spacecraft, but they survived that. NASA was worried about trying to turn them around because of what they need to do to turn something around when it's going as fast as it was going. And so instead, NASA decided to allow the Apollo 13 aircraft to continue on its path like this, whip around the moon, and then shoot back towards the Earth. And so what the problem asks is, how long from this accident to the time they land, how long does it take if they're going 25,000 miles an hour? And so what you see here is that you're being asked to just do a little drawing and figure out how far, what's the distance that they're going to travel after the accident. And so they see that it's 137,000. They come back around the moon, and then they have to do another 100 or 238,000. And so the distance is going to be the combination of these two. After that, you'll have a velocity, and you'll solve for time. All right. Hopefully this helps you if you're watching it. And I will continue to do this for you guys in the future.